Physics, Chapter 18, Gravitational Fields. So this is a very interesting topic and interesting lesson. We'll be learning the basics of how gravity is actually used in calculations, but we will not be going into too much of theoretical details. That is for you to learn what gravity is. Gravity has been an age-old question, and it is still being. We are still trying to figure out how gravity is important and how gravity is acting and what causes gravity. There are a lot of things that we are still trying to figure out. But in a basic sense, gravity is the biggest problem in physics. Now, um, gravity is the most significant force that exists in the universe. Everything has a gravitational power. But for each and every cell of your body also has gravitational power. So perhaps that electrostatic force that exists between the protons and the electrons that circumnavigate it, they can also be understood to be gravity. So the uh, similar aspects are present in both of them. Now, the first thing that we have to deal with is how to represent a gravitational field. The reason why I told you that gravitational field and electric field strength, that they have somewhat common aspects, is because the gravitational field is also represented the same way that we represent electric field lines as well. So both are the same. Now, the arrows on the field lines show the direction of the gravitational force on a mass placed in the field. The spacing of the field lines indicate the strength of the gravitational field. The further apart they are, the weaker the field. So now, as you can see here, uh, close to the Earth's surface, they are quite close to one another. Right? The gravitational field lines are close to one another. At these points, they are close. But further apart you go, they become much more spreaded. So as a result, you can understand, further away you go from an object, the gravitational field strength is going to decrease. Right? So that is something that you must understand. Then at the same time, the gravitational field of the Earth is as if its entire mass was concentrated at its center. Right? So, as far as any object beyond the surface is concerned, the Earth behaves as a point mass. So, Earth is a point mass. So, we are all attracted towards the center of the Earth, as if it is the center of the Earth that holds all the mass. So, that is something that you must, try to memorize. So, it is even though the entire uh, Earth has gravity on it, it acts as if the Earth, it is the center of the Earth that has all the mass. Then, if you go to the surface of the Earth, and if you look at some small place like the side of this building as shown here, uh, they will show that the gravitational field lines are more or less uniform and parallel to one another. Why? Because Earth is huge. In comparison, the field lines are, they will appear to be, they will have a uniform aspect everywhere, and they will have, even though it is radial, that is emanating from a central point and going in a spherical pattern, even though it is radial, it acts as if it is parallel, very close to the Earth. Because the field lines are equally spaced, and you know if you take if you take a planet such as Jupiter, it is huge, it is massive compared to the Earth. Uh, there the field lines would be much more closer, because larger the object, higher would be the gravitational field strength. So as a result, we will have to show it very quite close to one another. Right, let's write down a note. The Earth's gravitational field can be described as a point force acting towards the center of the Earth, which spreads out radially in a uniform manner as shown in below diagram. Draw this diagram, figure 18.3. You don't have to draw the maps of the world, just a sphere would be sufficient. And draw broken lines to represent that represent the represent that they all converge at the center. I'm not actually, it is not very clear, but it should be not exactly a set of dots, but rather a line like this. They should connect at the central point. That's I want you to show that it is coming together at the center or emanating from the center. So draw that as well. Then after you draw, write down closer to the Earth's surface, the field lines are parallel and evenly spaced. Suggesting that G is the same, simple G is the same everywhere you go in this gravitational field. However, further away you get from the center of the Earth, lesser would be the power of G. As a result, field lines are spread apart. I hope you understood. If you have any questions, please raise them.